The vast cosmic tapestry, while breathtaking in its grandeur, harbors within its depths a silent and persistent menace, the ever-present threat of celestial collisions. Among the myriad asteroids and comets that traverse the solar system, one particular object has captured the attention and concern of scientists and astronomers worldwide. The asteroid designated 1950 DA. This celestial body, a rocky behemoth with a diameter of approximately 1.3 kilometers, is currently projected to intersect Earth's orbit on March 16, 2880, a date etched in the annals of astronomical predictions with a chilling potential. The sheer scale of the potential impact is staggering. 1950 DA is estimated to be hurtling through space at a velocity of 15 kilometers per second, a speed that translates to an immense kinetic energy upon impact. The calculations conducted by NASA and other space agencies suggest that such a collision would unleash an explosive force equivalent to 44,800 megatons of TNT. To put this into perspective, the largest nuclear device ever detonated, the Tsar Bomba, released an energy of approximately 50 megatons. The potential impact of 1950 DA, therefore, dwarfs even the most powerful human-made explosions by nearly 1,000-fold. The predicted impact zone, according to current models, lies within the Atlantic Ocean. While the precise location and angle of impact remain subject to refinement as our understanding of 1950 DA's trajectory improves, the consequences of such an oceanic collision would be catastrophic. The sheer energy released would generate a massive tsunami, a wall of water hundreds of meters high, capable of inundating coastal regions across the Atlantic basin. The resulting devastation would extend far beyond the immediate impact zone, with coastal cities and low-lying areas facing inundation and destruction. The implications of such a tsunami are manifold. The initial shockwave would be followed by a rapid and devastating rise in sea level, flooding coastal communities and displacing millions of people. The force of the water would pulverize infrastructure, destroying buildings, roads, and bridges. The saltwater intrusion would contaminate freshwater sources and agricultural lands, leading to long-term environmental degradation and food shortages. The economic costs of such a disaster would be astronomical, potentially crippling global economies and triggering widespread social unrest. Beyond the immediate tsunami, the impact of 1950 DA would trigger a cascade of secondary effects. The massive explosion would eject vast quantities of dust, debris, and water vapor into the atmosphere. This atmospheric plume would block sunlight, leading to a period of global cooling known as an impact winter. The reduced sunlight would disrupt photosynthesis, leading to crop failures and widespread famine. The altered climate patterns would also trigger extreme weather events, such as torrential rains, powerful storms, and prolonged droughts. The impact winter would also have profound ecological consequences. The sudden drop in temperature and reduced sunlight would disrupt ecosystems, leading to mass extinctions and biodiversity loss. The delicate balance of ecosystems would be thrown into disarray, potentially triggering cascading effects throughout the food web. The long-term effects of such an ecological upheaval are difficult to predict, but it is likely that the Earth's biosphere would take centuries, if not millennia, to recover. The threat posed by 1950 DA is not merely a theoretical exercise. It is a tangible and quantifiable risk that demands our attention and action. The fact that the predicted impact date lies nearly a millennium in the future does not diminish the urgency of the situation. On the contrary, the long lead time provides an opportunity to develop and implement mitigation strategies. NASA, along with other space agencies around the world, is actively engaged in efforts to track and characterize 1950 DA. This includes refining our understanding of its orbit, size, and composition. The goal is to improve the accuracy of our impact predictions and to assess the feasibility of potential mitigation strategies. One promising approach is the development of asteroid deflection technologies. These technologies aim to alter the trajectory of an asteroid, diverting it away from a collision course with Earth. Several methods are being explored, including kinetic impactors, which involve sending a spacecraft to collide with the asteroid and nudge it off course, and gravity tractors, which involve using the gravitational pull of a spacecraft to gradually alter the asteroid's path. Another potential strategy is the use of nuclear explosives to deflect or fragment the asteroid. While this approach carries its own set of risks and challenges, it may be necessary in the event of a late-stage discovery or a particularly large and threatening asteroid. The development and deployment of asteroid deflection technologies require significant investment in research and development. International cooperation is essential to ensure that these technologies are developed and deployed in a responsible and coordinated manner. The threat posed by 1950 DA is a global challenge that requires a global response. Beyond the technological aspects, public awareness and education are crucial. It is essential to communicate the risks posed by asteroid impacts and to foster a sense of shared responsibility for protecting our planet. Public support is essential for securing the necessary funding and political will to address this long-term threat. The story of 1950 DA is a stark reminder of the fragility of our existence and the importance of planetary defense. While the predicted impact date lies centuries in the future, the time to act is now. By investing in research, developing mitigation technologies, and fostering international cooperation, we can safeguard our planet from the devastating consequences of a celestial collision. The 2880 date, while seemingly distant, should not create a false sense of security. The time to develop the necessary technologies, to create international agreements, and to test mitigation strategies is now. The long lead time allows for a deliberate and measured approach, but it also demands a sustained and unwavering commitment. The threat of 1950 DA is a call to action, a reminder that we are not passive observers in the cosmic drama. We are active participants, capable of shaping our own destiny. By embracing our ingenuity and working together, we can ensure that the looming shadow of 1950 DA does not cast a pall over the future of humanity. Instead, it can serve as a catalyst for innovation, collaboration, and a renewed appreciation for the preciousness of our planet. The challenge is immense, but the stakes are even higher. The survival of humanity may well depend on our ability to meet this challenge with courage, wisdom, and foresight.